Adding and subtracting polynomials. So we are not doing square roots today. Our work today has some exponents in it, but we're doing a lot of combining like terms. So remind me of what it means to combine like terms. Combine what? Combine the same numbers. So like those numbers that are all alone, they're called constants, like a 2 and then a -8. That's called a constant. Those numbers are like terms. What other things are like terms?
2x and 3x.
2x and 3x. They both have just x to the first power. Even x squared. 9x squared and -15x squared. They both have x squared, so they're like terms. So the first thing we need to do is kind of talk about just the basics of everything so that you are clear on what everything's called and such. So the objective, the goal is there. Can someone read it for me? Yes, Alex. Sorry, that means, go ahead, picked on you. The goal on the top of your paper that's right in front of you. Okay, classify means to give a name. It's very much a science word, okay? You give it a name. We're going to talk about how many terms it has, what degree. Degree means exponent. And coefficient. So there's a lot of vocab here. Let's talk about them all. So standard form. Standard form is a way that we write math equations that have like x squared or x to the first powers. It's this. First off, A and B and C are going to be numbers. So if I write A, which I will, A x squared. A is a number, any number. 17, 38, whatever. Okay, plus bx. B is a number. So I've got x to the second power, and I've got x to the first power. And then this c is just going to be a number at the end. It's going to be like a constant, a number at the end. So that's the format, the order that we write our answers in. The second power has the highest number, x squared. So it's in front because it has the biggest exponent. X to the first power will go next, and then the number that's just a number and doesn't have a variable, the c, goes at the end because it's really not that important. It doesn't have any power or significance. Okay. So you'll notice over on the right side, I've got this example here. This one is to the third power. So it goes in front because 3 is bigger than 2. 2 is bigger than 1, and so on. Okay? Leading coefficient. It's the number in front of the highest power. Like, so since this math problem's, sorry, I'm going to need to turn off my rotation. Since this 2x to the third started with the x to the third, the 2 is the leader. It's the coefficient in front. The word coefficient, by the way, that word, let's remind ourselves of that. Does anyone remember a coefficient? The number in front of x, or y, or z, or whatever. So the number in front of a variable. Okay, degree of the polynomial. That's going to be the highest or the largest exponent. So in this example, it's the 3. It's the little power, that 3. We would say that this is to the third degree because there's a third power. And then classify by number of terms. A term is separated by plus signs and minus signs. So here we go. 1 term, 2 terms, 3 terms, 4 terms. My red little underlines. Those are terms. They're separated by pluses and minuses. There's 4 of them in this one. This example, there's 4 terms. 1, 2, 3, 4. So classify by number of terms. That's how many different, what's a word? How many different, I don't have a good word. How many different numbers there are, or because it could also have an X or a Y with it too. Many different, I'll put numbers, but I really don't like that definition. Anyways, it's separated by a plus or a minus. Okay. So these are all called polynomials because it's a group of numbers and x's and y's all together. Polynomial. If something only has one term, oh my gosh, I'm recording. If something only has one term, it's called a monomial. Monomial. Mono, one. Monocle, a little eyeglass with one lens, monocle. Monotone voice, I never raise it, I never lower it, I speak the same all the time, monotone, mono. Okay? If something has 2 terms, let's do red. Binomial. Bicycle. Bifocals. So the glasses have 2 different lenses, and one of them is for like looking up close. Old people have them, you know. Bifocals. Okay. Bifold, 2 folds in like paper. What do you think 3 terms would be called?
Trinomial.
T-R-I. Yep. Tricycle. Triad. 3 things. Tell me some words.
Triangle.
Tri-tip. No, that's not one. Triangle, 3 sides. Triceratops has 3 horns.
Wait, does it?
No, it does.
It does?
Wait,
Come on, boys. I know you had like a dinosaur addiction when you were 4 years old.
Triceps.
Triceps. Are there 3 muscles in there?
absolutely.
Okay. So, here we go. But that was the best tri-tip. Tri-tip, that's the best. Okay. More than, I don't even have a word for this next one. Or how about 4 or more? Polynomial. Because we're not going to do for 5 a different word, for 6 a different word. So we're just going to do polynomial. 4 and more. There's no quadnomial. Polynomial. What is my example on the upper right? Is it a monomial, is it a binomial, is it a trinomial, or is it a polynomial? It's a polynomial because there's 4 terms. Okay. Whew. That is on the top of your paper. You're going to continually need to use that because for every single example on the front side, we are identifying. So, your paper does not have what my paper has. Your paper does not have the words leading coefficient, degree, and number of terms. So here's what I want you to do, otherwise your hand is just going to get so tired. Leading coefficient, title it LC. Degree, D. Number of terms, you can put, I don't know, number T, whatever. Number sign and T. I just don't need you to write out those full words for every single problem. Okay, so 6, it's just one thing. There is no x or y. There's no exponent. So I want to know, what's the leading coefficient? What's the number that's in front? Is this even, this is not even a coefficient, you guys. What's this called when it's a number by itself?
Constant.
Constant. Degree, is it to the first power, second power, third power? First power. And how many terms do you see with 6? Just one. Okay, so we're slowly going to get a little more difficult. Negative 2x, what's the coefficient that's leading it? Negative 2. What degree is that x? First. How many terms do you see? You do not see 2. You do not see 3. 1, because the whole thing is a term. You cannot separate out a negative and the 2 and the x. There's no plus sign and minus sign in the middle of them. It has to be separated by an addition or a subtraction sign. Okay? Three and 4. Number 3. Okay, first of all, it's written in the wrong way. X's will always be more important than just like the 1. So please write 3x plus 1. We need to make sure that we're always writing our answers in order. An x has more significance than just a number, because it's x to the first power. So now what is my leading coefficient? 3. What degree is the x to? First. How many terms does this have? 2. Just for clarification. 1, 2. 1, 2. Oh man, number 4 is written wrong too. Let's write it in the proper order. What's the biggest exponent? The negative x squared. That goes in front. Don't forget that there's a negative sign in front. Negative x squared. What then is like second in command? What's the next most important thing? Is it positive or negative? Good. So put the plus 2x. What's the last thing that's all by itself at the end and not really that important? Now we can start. Okay. A leading coefficient means that the number that's in front of the biggest exponent, well, that's squared. What number is that? Negative 1. What degree is this to?
2.
You say like second. You can't say 2 degree. It's to the 2 degree, second degree. Number of terms, how many do you see there? Separated by a plus sign or minus sign. I'll circle them. 1, 2, 3. Does this seem easy so far? Super simple? Okay. Do 5 and 6 on your own. On number 5, what's the leading coefficient? On number 5, what's my 4? What degree is this to? Third. Thank you for saying it the right way. How many terms do you see there?
2.
1, 2. Okay. Did you put number 6 in order first?
Yes.
Was your order this?
Yep.
Cool. What's my leading coefficient?
2.
What degree? The biggest exponent?
Fourth.
Fourth. TH. How many separate terms do you see? 1, 2, 3, 4. Okay? Now that we know how to identify everything, we're going to get into actual adding and subtracting things that are the same. Okay. You need to come up with a system. Come back to me. Stay with me. Thank you. Here's what I mean when I say system. When I first taught this to you back at the beginning of the year, I do silly things like zigzag, underlines, put a square around it, put a star above it, circle it, whatever. So you have to think of a way that you've got, here's what you've got. You've got this chunk, and this chunk, and you need to combine all the things that are the same. So look for the highest degree and start there. Always start with the highest thing. X to the what? X to the third. Okay, so it's all alone actually, isn't it? Okay, please notice that I'm adding here, plus and plus. If there were a minus sign, I'd have to distribute that negative sign, the minus sign. But right now it's all pluses. So the x to the third, it has a negative 1 in front of it, right? So there's going to be negative 1 x to the third all alone. Because there's nothing else like it. I cannot combine any like terms. So it's alone. Let's do all of our x squareds together. Think of a system that you're going to remember. I'm going to put a star above all the x squareds. Okay. There's 4 of them. So you have to put them all together. So you could organize it like put it on the side somewhere. You could do the 5x squared plus 2x squared, positive 3x squared, and positive 4x squared. When you add all those x squareds together, the backpack, the x squared stays the same. Don't make it x to the 4th, x to the, no. It stays x to the 6th. It stays x to the 2nd. Just add the numbers. 5 plus 2 plus 3 plus 4. What is it?
14.
14. And then you attach the x squared because that's what they all have in common. Okay, what's my next thing that I need to worry about? Just plain old x's. Okay, here's a negative 1. Here's a negative 4x. Put them together. A negative 1x and a negative 4x. Negative 5x. I'm almost done. What's my last thing?
Constants.
Constants. 7. Negative 8. 7 plus 7 plus negative 8. 14 plus negative 8. 6. Okay? I'm lucky because I have colors. So, you have to decide, are you going to make little sections and add them on your paper? Or are you going to add it in your head? Whatever you decide to do, come up with a system that you know is going to work for you. Okay, number 8 has a negative sign in the middle. You guys, that's like negative 1. So all of the numbers in the second parentheses are going to change. Because look, Negative 1 times that, negative 1 times that, negative 1 times that. So go through and you're going to have to change the signs of all of those second parentheses. Because there's a subtraction sign, I'm going to have to subtract negative 2, subtract 3x, and subtract negative 4. Which means that it's going to look like this. Positive 2x to the third. I'm going to distribute negative 3x and positive 4. Those are my new numbers that I'm working with because I had to work with the subtraction sign. Some people, some teachers, I'll do this in green so you can see what your alternatives are. Some teachers are totally fine with you doing something like this. Plus 2x minus 3x plus 4, and actually physically changing the signs and then getting rid of the middle thing. So you can shortcut it by just changing the signs right in front of the numbers, or you can rewrite the whole thing with the new positive negatives. This only happens with subtraction, by the way. Only happens with subtraction. Okay, now that I've changed the signs of everything, do it with the people at your table. The third powers, what did you get? To the thirds, what did you get? They canceled out, nothing. It was canceled out and made 0. When you combine these squareds, x squareds, what did you get?
5x.
5x squared was alone. When you combined the x to the first power, what did you get? Yeah, negative 1x and negative 3x. That makes negative 4x, you're right. When you combined the constants, what did you get?
Negative 4.
Negative 8 plus 4, negative 4. Did you guys get this right here? Ooh, distribute negative 2. Negative 6 plus 18x squared plus 4x. Okay, x squareds are underlined. X to the first power, 4x and 2x are green. Black will be the negative 3 and the negative 6. You have to lead with the purple. 7x squared plus 18x squared. 25x squared. Now go to the greens. 2x plus 4x. 6x. Now the black. Negative 3, negative 6.
Negative 9.
Okay. So, you have your quiz tomorrow. Here's what I need from you.